Dude, you're such a square. You ever hear that before? You maybe haven't heard that before. That's actually an older saying, such a square. It was like it was like a derogatory term almost. Not that bad, but like you're such a nerd. You're such a weirdo. You're a square. Well, I just thought of that when I was thinking about this lesson, which is going to be all about equations that include powers or radicals. And remember, powers are exponents, and radicals are like square roots and cube roots. We'll say roots. So I'll put that square root symbol as a reminder. Because they're radical, dude. But anyway, we have three goals. They all kind of go together, but I put it into three goals because, well, we're going to touch on all three of them. I can solve simple equations where the unknown, so like the x, is squared or cubed, so it has an exponent. I know that squares and square roots are inverse operations, so same thing with cubes and cube roots. And then I can also solve simple equations that include square or cube roots. Okay? So let's first review inverse operations. So thinking back to when we solved equations, that whole unit on solving equations, we used inverse operations to undo things. Um, and so inverse operation of addition is subtraction. Because if you have addition, you can undo it with subtraction. Um, and I'll give you an example. X plus, x plus 3 equals 6. You undo it with subtraction, so like subtract 3 from both sides to cancel that out, and then you have x equals 3. So that's just a good example, just to refresh our memory on those inverses. Say likewise, the opposite of subtraction is addition. Okay, so the same thing, just opposite. The inverse operation of multiplication, so like we have 3x equals 6, that's multiplication. The inverse would be division. And again, we would undo it by dividing by 3. Dividing by 3, and you get x equals 2. All right, I'll erase that one. And then finally, the inverse operation of division is multiplication. And a good example of that too would be like x divided by 3 equals 6. And to undo that, we do the inverse, which is multiplying by 3. So I'll use parentheses or a dot to cancel out dividing by 3. And you get x equals 18. All right. So that's just a good review again of inverse operations. I keep bumping things here, sorry. So just like we did inverse operations with solving equations for those basic operations, roots and powers are the inverse operations of each other as well. So in other words, let's do this. If you have 5 squared, that's equal to 5 times 5, or 25. The inverse of that would be square roots. So now let's go from 25 and go backwards. The square root of 25 is 5, because 5 times 5 equals 25. So if I were to take a 5 to the 5 squared, and if I want to get rid of, let's just say, well, yeah, I want to get rid of and do the inverse. If I take the square root of that thing, the square root of 5 squared, you're left with just 5. That cancels out the exponent. Okay, square roots and square like the exponent of 2 cancel each other out. And if I started with the square root of 25, the opposite of that would be squaring the whole thing, and that cancels out and just becomes 25. So again, if you square root something and you square something, they kind of cancel each other out. All right? Likewise would be with cubing. So let's say, um, sorry, I keep bumping buttons. If you cube something like, let's do 2. 2 cubed just means 2 times 2 times 2, or in other words, it's going to be 8. Inverse of that would be taking the cube root, we talked about this in chapter 1, of 8, which is 2. Because 2 times 2 times 2 gets you to 8. So, if I were to do, let's say, 2 cubed, and I wanted to undo that, I would use the inverse, and I would take the cube root of it, and then I'd get just that 2 by itself. And this will come in handy, so that'll cancel that out. This will come in handy when we do solving equations with these. Same thing if I'm going backwards. If I have the square root, cube root, sorry, of 8, and I want to undo that, I'm going to cube it. So raise it to the power of 3. And those things kind of cancel each other out. And I'm just left with an answer of 8. Okay? So, just to recap here, I have a couple of questions. So the exponential inverse, the inverse of the cube root of x, would be the power of what? So what power would I have to raise this to sorry, to undo the cube root of x and just get it to x? It'll be the power of 3. So remember, if you raise it to the power of 3, that'll cancel those out, and you're just left with x. Okay? One other quick question. When an exponent is raised to its inverse, it will result in a power of 1. True or false? So technically that is true. So like we can say up there, x squared, and if we do the inverse of it, which would be the square root of it, those cancel out, you're really left with x to the power of 1, or we just say x. But that is the same thing as the power of 1, so that would be true. So now that we've covered all of that with the inverse operations when we're having powers or radicals, let's actually solve a couple equations that deal with those. So you can actually see what we're doing with those. So I have 4 steps that I'm going to suggest that you write down for solving equations that have powers or roots. First, I want you to use regular inverse operations, like we've done before, to isolate the power or root, so the power or radical. Then apply the inverse. So what we just talked about with the inverse of powers is roots, and roots is powers. And then remember, what you do to one side, you must do to the other. And then simplify to solve. So it's going to be similar to what we just did, but we're going to be doing it 2 sides of an equation. So actually, I'll leave that up. I have 3 problems here that have square roots. And we're going to take them one at a time. So, we want to get the x all by itself here on this first one. Number 1. To do that, we have a square root. We need to undo that square root. So, by the way, the root is all by itself. So we're done with step 1. Apply the inverse. The inverse of a square root is squaring it. We just talked about that. And that'll cancel out the square root. Now remember, what you do to one side, you have to do to the other. So I also have to square the right side. So now the x is by itself, and whatever 10 squared is, that's what x would be equal to. So 10 squared is 100. So x equals 100. And if you think about that original problem then, if you plug in 100 for x, the square root of 100 is equal to 10. So that's how it'll work out. Now let's do it with a little more challenging one. We also have a square root here. And the root part is all by itself, so we're done with part 1. Now we're going to apply the inverse. So remember, the inverse of x, or of a square root, is squaring it. And what you do to one side, you must do to the other. So I'm going to square this side as well. Now, the left side, the square root and the square cancel each other out, and you're left with n plus 9. The right side, we're just doing 1 squared, which is 1 times 1, or 1. Now, there's no square roots, there's no powers, but we haven't quite gotten n by itself yet. So let's do minus 9 from both sides to finish it off. We have n equals negative 8. All right? and number 3. So apply the inverses to isolate the power or root. So right now the power or root, this root is not by itself. So we're going to do the inverse operation. If 9 is multiplied by it, we're going to divide by 9. And we're going to do that to the other side as well. So 90 divided by 9 is 10. So if 10 is equal to the square root of 25v. Okay? Done with that. Now the root is by itself, so we're going to apply the inverse to that root, which is squaring it. Squaring is the opposite of square rooting. I'm going to do that to the other side as well. Check number 2 and number 3. And now I'm going to simplify. We have 100 over here equals, these cancel each other out, so we just have 25v. And then our last step to solving this, to get v by itself, is dividing by 25 on both sides. And then v equals 4. 100 divided by 25 is 4. All right. That's all the problems I want to show you, the basic problems for solving with square roots. Now I have 2 problems that have powers in them. Okay? So let's follow the same steps that we're doing, only we're going to do the inverse operation of powers. So if I look over to the left, the power is all by itself. So the inverse of that would be to take the square root of it, because it's the power of 2, so the inverse is square root. So I do that. And what I do to one side, I must do to the other. Oh, what happened here? So I square root over here. The nice thing about the left side is the square root and the square cancel each other out. So x is all by itself. And you just have to figure out what the square root of 36 is. And that'll be 6. Because 6 times 6 is 36. And there's your answer. All right, last one. This one has a power of 3, but it also has a 4 in front of it. So we can't do anything until the power part is by itself. So if 4 is multiplied by it, we are going to divide by 4 on both sides to get rid of that 4. So we have x cubed equals 32 divided by 4 is 8. And we're going to do the inverse of this power. So the inverse of a power of 3 is a cube root. And I have to do the cube root on the right side as well. And when I simplify, this cancels out with this. So x is alone. And the cube root of 8, so what times itself again gets you to 8? That would be 2. Because 2 times 2 times 2 equals 8. Alright? So again, these steps, these examples are very important to have in your notes, to have written down, to be able to use. And these are the basic ways to solve equations. Goal 1, where the unknown is either squared or cubed. Goal 3, where there includes a square root or a cube root. And then goal 2, just knowing that those are inverse operations. We did plenty of examples with those, and I hope it stuck with you. If you take the square root, that's the inverse of a power of 2. The inverse of power of 3 would be the cube root. All right? So I hope you learned something here about equations that have powers and radicals. I hope you're keeping it radical. And have a great rest of your day.